Hey, Mr. Estrada here, and in this video I'm going to show you how we can solve systems of equations by elimination. So here are the list of steps and guidelines that I'll be using, and this right over here is example 1, and it will be our only example for this video. So let's go over it. Solve the following system of equations algebraically. So the first step or guideline says, keep in mind that the first objective is to eliminate one of the variables. So we got two variables here, makes it very difficult for us to solve for any one of them, so we have to eliminate one of the variables. So then the second step says, multiply the top equation by the leading coefficient of the bottom. So the leading coefficient of the bottom equation is 4, so I'm going to multiply the top equation by 4. Then it says multiply the bottom equation by the leading coefficient of the top. So the leading coefficient of the top equation is 3, so I'm going to multiply the bottom equation by 3. Then it says, if necessary, negate the leading coefficient here. So you want to make sure that you have opposite signs here so that after you distribute, you can eliminate these variables. And as of right now, this is going to be a positive times a positive, which is a positive, and this is going to be a positive times a positive, which is a positive. But we want to make sure that one of them comes out negative. So I'm going to negate the leading coefficient here. Then it says distribute. So let's go ahead and distribute. So we're going to distribute at the top. So you distribute all throughout the equation, even after the equal sign. So we will get 12x plus 8y equals 16. Right? 4 times 3x is 12x, 4 times 2y is 8y, 4 times 4 is 16. And then in the bottom, we got negative 3 times 4x, that's negative 12x. Negative 3 times 3y, that's negative 9y. And then we got negative 3 times 7, that's negative 21. So what will happen is the leading variables will be eliminated. One is 12x, the other is negative 12x, so they cancel out. That's why I was very adamant about, in the beginning, making sure that these leading coefficients have opposite signs. So now we gotta combine. So 8y take away 9y is negative 1y, bring down our equal sign. 16 take away 21 is negative 5. So we're just going to divide and solve now. Divide both sides by negative 1. And we will get y is equal to positive 5, because negative divided by a negative is positive. So y is equal to 5. The last step is to solve for the other variable by substituting the answer you just found into one of the original equations. So let's take one of the original equations. We'll take the top one. It was 3x plus 2y equals 4. And we're going to substitute this 5 into the y so we could figure out what x is. So it's going to be 3x plus 2 times 5 equals 4. So that's going to be 3x plus 10 equals 4. Subtract 10 on both sides. These will cancel, so we get 3x equals negative 6. Divide both sides by 3. And we get x equals negative 2. So our final answer is x equals negative 2, y equals 5. We can also write it in coordinate form. We can say it's negative 2, 5. That is our final answer. All right. Now, we could check our answer, so let's go ahead and do a quick check. If we again take one or both of the original equations and substitute for x and y, we should get a satisfied equation. So let's take the bottom one, 4x plus 3y equals 7. Now remember what we said, right? We said x equals -2 and we said y equals 5. So we're going to substitute into this. So it's going to be 4 times -2 plus 3 times 5. And that should equal to 7. Let's see if it does. So we're going to get -8 plus 15 equals 7. 15 take away 8. That is 7. 7 equals 7. So checked out right there. Now, if you're wondering why I wrote this in a coordinate form, I'm going to show you why. This is actually a point of intersection for these two lines. So let me just go on Desmos.com real quick here to show you what these lines look like. Right. So Desmos.com. The nice thing about Desmos is that we don't have to put the equations in y equals form, so it will do that part for you. You can just enter the equations as is, and it will show us the point of intersection. Let's give it a minute to load. Alright, so the first equation was 3x plus 2y equals 4. So it's that line right there. And the second equation is 4x plus 3y equals 7. So it's that line there. Now, where do you think they're going to intersect? They're going to intersect right over here at -2, 5. That's the point we had found earlier. So the solution is basically the point of intersection of the two lines. All right, that wasn't necessary for this problem, but just to give you some food for thought. So I hope this helps. Take care.